Welcome Math 20-2 to your third lesson in measurement. Today we're looking at rate of change. So we're going to bring in the rates from before, except now we're looking at graphing and how they look like when we're graphing. So here we have Robin. She's preparing to make taquitos for supper. Okay? She preheats the oven to 400 degrees. Now, the graph shows the temperature of the oven as it warms up. What does the point 050 represent? Well, the point 050 represents our initial temperature of the oven. Oops. Which is at 50 degrees. Okay? Then it says, what does the point 5 and 400 represent on the graph? Well, that tells us how long it took us to make 400. It took to reach 400 degrees, okay, Fahrenheit. Now, and in this case, it took 5 minutes to reach 400 degrees Fahrenheit, all right? Now, let's take a look at the next one. It says, calculate the slope of the line by joining these 2 points. So we want to know the slope. Now, slope is always equal to rise over run. So, slope is equal to rise over run. In this case, it is equal to, we have 400, the change in y, that's 50, all over the change in x, which is going to be 5 minus 0. Okay? Change in y over change in x. In this case here, we're going to get 350. It's my change in y. 5 is my change in x. And we need our, this is in degrees Fahrenheit. This is in minutes. Degrees Fahrenheit, because it's a rate. Okay? Not a ratio. And we end up this. I get 70 degrees per minute. Okay, so it goes 70 degrees Fahrenheit per minute. Okay, what does the slope of the rate of change? Okay, so the slope is a rate of change. Okay, the temperature is divided by the time. What units are represent this rate of change? This is degrees Fahrenheit per minute. Okay, now complete the following sentence. The temperature is increasing or decreasing. Well, if we notice, it's a positive slope, so it's increasing at a rate of 70 degrees Fahrenheit per minute. Okay? Now the next one here is very similar, except we're looking at a bath of water. So it says water is leaking out the bottom of a barrel at a constant rate. After 2 minutes, the water level is 62 centimeters. After 7 minutes, the water level is 22. So here, this is going to be always time on the bottom, minutes and time. And this is going to be water level. Okay? So in 2 minutes, after 2 minutes, water level is 62. So that's 2, 62. And after 7 minutes, 7, is 22. Okay? So on the grid, ordered pairs, and the water level time. Calculate the slope. So remember, my slope is equal to rise over run, or change in x, change in y, over change in x. Now if I look at this, I would do my second point first, my farthest that way first. I have 22 subtract 62 all over, we have 7 subtract 2, which will give me negative 40 over 5, which is the same as negative 8. And what is this, sorry? Centimeters per minute. So this rate of change is going centimeters per minute, and it's going down, okay? So the water level is changing at a rate of negative 8 centimeters per minute. Or you could say the water level is decreasing at a rate of 8 centimeters per minute, okay? So let's take a look at our last example here. It says, Dave entered his car into a long-distance car race. He traveled 150 kilometers in the first 2 hours. Okay? After 6 hours, he traveled 650 kilometers. Okay, so plot the ordered pairs. And why are we going to start at 0, 0? Because we're at a race, and this is going to be my time. And this is in kilometers, right? And this is going to be my, or time not in kilometers, time in hours. And this is going to be my distance in kilometers. So remember, it always goes, time is almost always on your x-axis, okay? And why does it start at 0, 0? Because at 0 time, he traveled 0 kilometers. It's the beginning of the race. He hasn't gone yet. So calculate Dave's average speed between the 2 hours. Oh, so first of all, it wants us to put these in. So after 2 hours, he did 150 kilometers. So this is 2, 150. And on top here, we have, okay, after 6 hours, he had traveled 650. So that's 6, 650. Hopefully you see that. And that's this point up here. So we have my 2 points. 6. Calculate Dave's average speed between 2 hours and 6 hours. Wow. Is this considered a rate of change? So now we're going to calculate Dave's average speed between 2 hours and 6 hours. So we want the slope from here to here. Okay? So we have a change of, we do the second point first, we go from 650, because we want change in y all over change in x, because that's my slope, rise over run, 650, subtract 150, all over, and we go 6, subtract 2. So that's all over 4, and we end up getting here 500. So my rate of change is going to be 125, and what is that? Kilometers per hour. All right? Now, this is a rate of change of distance to time. Okay, so this here is actually a rate of change of distance to time. Okay? Now, number C says, by looking at the grid and without doing any calculations, can we tell the average speed during the first 2 hours was less than the average speed in the second 2 hours? Well, yes, we can. Yes. Why? The slope is not as steep. Or it is less. Okay, the slope is not as steep or less. Okay, now let's take a look at the next one. It says the graph shows the representation of fuel in Dave's gas tank as a function of distance traveled during a portion of the race. He drove at a constant speed. So from here to here. Calculate the slope of the line. Once again, slope is equal to rise over run. Well, here, we're not rising, we're going down. So we have, which is equal to change in y all over, change in x, which is equal to here, we start the second one, 40, 50. So 40, subtract 50, and my x is 120, subtract 20. Which gives us negative 10 all over 100, which is 1 over 10. And what is that? That is, kilometers. And that's tank N per kilometer. So that's liters in fuel, which we said is N, not liters in this case. And that's it. Now, it says complete the following. The amount of fuel in the tank is increasing or decreasing. Well, it's a downward slope. It's going down from left to right. We go down, therefore it is decreasing. The rate of change of fuel in the tank is, negative 1 over 10, and that is liters, or in this case, N per hour. Okay? The amount of fuel in the tank is decreasing at a rate of, I could say 0.1 or 1/10, and that should be liters, or I'll just put that, per hour. Okay? I'm going to put it as liters. I don't know why they have an N there. It doesn't make sense. Fuel tank, N, so I'll go L, liters. Okay? So everything's going to be in liters. I'm not sure why they put that in. So I'm going to just put that liters. So that's how we solve it. Hopefully you understood this rates of change. Good luck on your assignment tomorrow, and make sure you ask any questions if you have them.